Today we're talking about measures of central tendency. In other words, averages, but there's more than just averages. The three most common are the mode, the mean, and the median. And each of them tells us something about the data that gives us an idea of what the average is. Okay? Because sometimes our most common average, which is the mean, isn't a very good indicator of what's happening. For example, you work for a company. The company has 100 employees. 99 of them work for minimum wage, and the boss makes $1 million a year. So if you were applying for a job there, and you said, what's the average annual salary? It would be really high, because you have that outlier of the boss making $1 million. Okay? Meanwhile, everybody else, what's minimum wage right now? $11.15. Okay? So everybody else is making $11.15. Okay? In that case, the median, which is the middle value, is asking, what does the person who's in the middle of all the wages make? Well, he's making $11.15. You're like, oh, an hour, as compared to the average, which was $750 an hour, or something insane because of the boss. Or the mode, and the mode is the first one that we have here, the one that happens the most. And that might be helpful for you, because if you're joining the business, you're going to be like, I'm probably one of the lowest end to start with. What do most people make? Oh, they make $11 an hour. Okay, that's not necessarily the greatest job. Because if most people make $11 an hour, how many years do I have to be in the business before I'm at the top of the $11 an hour people before I can move to that next level? So each of these measures of central tendency have their purposes. Most of your experiences up till now in your life, the mean or the average is the one you're used to, and it in most cases makes the most sense. But there are situations where the other ones are important. So we have a set of data, and the data is all over the place. So to find the mode, one of the things that's helpful is to organize your data. So if we rewrite this data in order from biggest or smallest to biggest, we can start to see some patterns. In this case, it's easy to see that the mode is 12. It happens the most. You can also see modes from a frequency chart. So again, understanding what the frequency chart says, this says that the mark of 50 happened 12 times, the mark of 60 10 times, the mark of 70 10 times, the mark of 80 5 times, so the mode would be the 50. It happens the most. For me, that's how I remember the definition of mode, because it rhymes with most. I don't know. There's not an English word for the beginning of a word starting with the same as another beginning of the word, right? But there should be, because people use that all the time. Especially when they want to pretend that they're going to swear, but then don't, right? Fudge, shoot, okay? A very famous Spanish one is Wednesday. Okay, well, they don't say Wednesday, but in Spanish they say miércoles, because the first part is very close to the French swear as well. So, anyways, so we have these things that helps me remember most and mode. And when you have group data, So here the data is grouped from 60 to 70, 70 to 80, 80 to 90. We don't have a mode, and you might think, well, should I put 75 as the mode, but now we'll call it a modal class because it's a group of data that combines it, that your mode is within that group. Well, it's that whole, in that group you have the most, okay? If we put this into our calculator, we would put 65 once, 75 6 times, 85 5 times, right? To find an estimate for the mean, that's what we would do. And so an estimate for the mode would be 75, but we would say in this group data, we have a modal class. Mean. This is your usual average, where you add up everything you have, divide by how many you have, and you get your average. So here it's described in words, sum of all your data values, and then the total number of data values, divide by that. Now we can get into some fancy formulas. Have you seen the Greek letter sigma before? Okay? And that Greek letter has a mathematical meaning. That means you add up stuff, right? And we saw that on our graphing calculator the other day. Okay? This is one of my favorite Greek letters. You know, anyone know what that one's called? Mu. I like it because it kind of looks like an M, and it looks like a U, and you pronounce it mu. So it's just, I remember I learned this just the other day, so, I can't find it. It's a word I learned, and now I forgot it, so obviously I didn't learn it very well. I think the word is autological. And autological is a word that describes itself. For example, the word 15-lettered has 15 letters. So it is an autological word. Unhyphenated doesn't have a hyphen. So it's autological. So mu is sort of an autological letter because it has an M and a U. So this just says we'll add up all of the points, and n is how many terms we have. We divide by that. Now, notations, and we don't get deep into notations. When you study some high-level statistics, they'll really explain what it means between a population mean and a sample mean. So a population mean is when you take all the data that exists and find the average from that. Where sometimes the population is too big, and then you use a sample mean. And the notations are there. Those are two notations that I find are not, you know how IB is fussy in some things? I don't see that often coming up as a place where like, you used the wrong type of mean symbol, we're going to take off marks. That doesn't seem to happen very much. So here, we have the math marks. These are IB marks. And the average is 4.6. Okay? Often what I'll do with questions is I'll give you time to start working them on your own, and then I'll put up the answers. So for these two, I want you to think about these. Try to figure it out on your own. If you figure it out super fast, you can move on. So first, the setup, we have mark of 1 happens 0 times, mark of 4 happens 2 times. We have the mark of 4 happening k times, so that introduces our variable. And when we count the total frequency, it's 30 plus k. Simplifying that from there, we've got to solve for k. So the time that I gave you is probably enough to get started, maybe not enough to do all of your calculations, right? That being said, in a mathematics problem, the hardest part is getting started, right? Once you've set up the equation, and that's sort of where I wanted you to be at, did you get the setup correctly? The rest is some simple mental math and a little bit of algebra skills, which by now you guys are pretty good at. And the rest is details working through. And none of the details I find in this one were crazy or things that would trip you up. Lets us figure out that the mode has to be 4 because we now know this is 10. You can also calculate the mean from a frequency table, and you can do so by creating a chart and really figuring everything out. For the most part, though, because this is a lot of calculations that aren't hard and just sort of tedious, this is where we like to use our calculator. So we could put the lengths in list 1, the frequencies in list 2, and get our answer. But what's happening if you have the length of 10 happening 6 times, that makes a total for that be 60. Same thing with 15 and 12, 20 and 13. If you add up your frequencies, you have 35 in total. If you add up all of your totals that you've added up, you get 600 in total. The main thing here that I want you to see is some notation stuff. So the notation stuff, I've got at the bottom the sum of f and then the little I. The little I says this I changes. It's my first frequency plus my second frequency plus my third frequency plus my fourth frequency. So we would probably label this one as frequency 1, frequency 2, frequency 3, frequency 4. That's what that little notation is trying to talk about. Here, we're taking each frequency and multiplying by, this would be x1, this would be x2, this is the third x, that's the fourth x. So that's what that notation is saying. Okay? The rest of this, really easy to see what's happening. The notation is probably the part where you go, what? So that's all what I want to talk about there. Okay? So what's our mean? It's approximately 17.1. You would take 600, divide by 35. Look at that notation. And in a summation, so if I got you to do this, I want you to sum up all I, and I say on the bottom, I starts at 1 and ends at 3. What this means is you start at 1, plug it into the formula you have, and what would you get? 1. Perfect. Then, should we stop? No, we're supposed to go up to 3. So you come back down, what's after 1 is 2. Plug in 2, what do you get? 2. Do we stop yet? No, we're supposed to go up to 3. So this formula right here means 6. Yes? Right here, this is I equals 1. So what happens under the sigma sign and above the sigma sign are parameters for where I starts and where I ends. Okay? So you can write more complicated And it doesn't have to be I. I could say 2k plus 3 here, and I want to have k start at 2 and end at 4. So what would that mean? I'd plug in 2 first, and I would get 7. Then I would keep going. The next number after 2 is 3. I'd plug in 3. 6 plus 3 is 9. Then I'd plug in 4. And 8 plus 3 is 11. Add those up. And I get 27. Yes. Why is it 9 and 11? Did I add? They're just random. So, what we have is a summation formula. And sometimes you can get summation formulas that, here let's do, starts at 1 and goes on forever. Have you ever added up an infinite amount of numbers? Yes, you have. Maybe you remember this one. No, maybe. What happens when I plug in 1? I would get 4. What happens when I plug in 2? I get 2. Then I get 1. And I get half. It's an infinite series. Infinite geometric series. That formula for your infinite geometric series is in that 80-page booklet I gave you. It's not 80 pages. Yeah. So you remember this? Sum to infinity of an infinite sequence. That one? Okay? Except now, this is how you learned in grade 12. Now on your formula sheet, oh my goodness, how are you going to do this? They use U's instead of T's. So one of the things we're going to find on a formula sheet is we have the same formulas, and sometimes the letters are changed. Does that make them harder? No.
Can we still use the T?
Can you still use the T? If you wrote out the formula first with the T, that would be fine. It's the same formula. I like the T better too. Okay, I'm getting so excited about a whole bunch of math. Back to statistics. There is the formula for your mean. And that formula looks really, really scary. Except now if you think of this and can go back to here and say, oh, that just means I take the length multiplied by the frequency. I take the length multiplied by the frequency. I take my value multiplied by the frequency, add everything up. I still am dividing by everything that I had in total. It's the same idea, okay? But if you got to a test and you looked at this formula and you were like, hadn't really thought about it, it would be really scary, okay? In fact, sometimes that's what upper math is all about. Creating weird-looking symbols to make other people scared of how much you know. Go back to this one. Don't get this one, the 2k plus 3. So this part here is the formula. This value here is the start value for k. So if I start when k is 2, and I plug it in, what do I get? 2 times 2 plus 3, I get 7. This is where you end. So you go always up by ones until you get the value where you end. So after 2, we plug in 3. And then after 3, we plug in 4. Okay? There was a reason I didn't put 40 up there. I didn't want to do it a super long time. But that's what the notation means.
It's always 2.
What's that?
Always 2.
picked a formula. You can pick any formula in there. Okay? For example, this is a formula you learned in grade 11. Arithmetic sequences, right? How do you add up numbers? 1 plus 2 plus 3 plus 4 plus 5 plus 6. Right? There's a formula for that. You could create it. And so we can show what we're trying to find with the summation notation. Okay, I do want to get off topic on that, but I will try to stay with statistics because formulas of sigmas, so much fun. Statistics. Okay, let's go. So you can plug things in. There's your formula. You can use your graphing calculator to check your answer if you did it by hand. Although we had an issue with checking an answer before, we got to find the mistake. And when data is grouped, we estimate the mean by choosing that mid value. And we've done some of that already with our histograms as well. So here is some group data. And if we fill out this chart, we have our frequency already given to us. We can find the midpoint of each of those group values. Find out our total, find out what everything adds up to, and get an estimate for our mean. Here I'm going to put the decimal 0. It's an exact value. 94 was the right answer as an exact value. But why should I use 3 sig figs and the approximation sign here? Yeah, I'm estimating already in the middle, right? This isn't exact. We're using it as an estimation. And I think that's why a lot of mathematicians find statistics a little bit not their favorite math, because it's kind of like, well, it's kind of, yeah, 94-ish. It's like every answer in statistics ends with the word ish. So these next couple I would like you to try. I'll put up this answer as well so you can check. For this one, I will give you these answers because it is just sort of mundane calculations. So you would multiply your mid-height by the number of flowers. If we add them all up, there's 85 in total. If we add those all up, we get 1285. What's an estimate of the mean? Approximately 15.1. And so for group data, there's the fancy formula for everything that we did. Again, if you look back at the example, you can just do it, but does the notation make sense? This data is continuous, and we would say it has a modal class between 10 and 20 because it's grouped data. So again, that idea of modal class. You can always plug things into your graphing calculator to check, and you should be getting the same answers. Yes?
So So I noticed that between like modal class and 50 to 10, doesn't like let's say for example 13 and 17 is still
Modal class, sorry, say that again. The modal class on that last one. Oh, of course I did that. Modal class is from 10 to 20. So what was the question? Sorry.
I've noticed that like we're talking about modal class, right?
Mm-hmm.
So was that a good sense of example 10 and 20?
No, it doesn't have to. That's a good question. Like all of the examples we've had have had our class groups between 10 and 20. It would depend on whatever data they're looking at. Maybe data made sense to group by 20s or by 15s, right? Or if you were measuring things and you were using inches, you might have modal classes that were between 0 and 12 inches, 12 and 24 inches, 24 and 36, because you're using feet, right? So it really depends on the question, but it does not have to be by tens. But what's good about what you did is you're looking for patterns, okay? And when you're learning math, that should be something always on your head. You're wondering, I noticed this, I noticed this, I noticed this. Does that always happen? If you become a math teacher, this is a very typical question students ask you. Well, I got this, 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 and this. What do I have to get on my last test to get an average of 80? What do your math teachers tell you? Have you ever asked that question? No? The most typical math teacher answer to that is, figure it out. And now you're going to say, well, that wasn't fair because it was a grade 12 IB math question. Well, this isn't really that hard. So what do we know? We want it to add up to 80%. I changed it to decimals. You could use whole numbers here too. Both would be the same. And we add the variable x because we don't know what that score is, but we're going to divide by 6 to make it work. Adding those all up, I multiply both sides by 6. All those decimals add up to 382 or 3.82. Not getting the 80. Yeah. That's the other reason we don't figure it out for them. It's just too disappointing. And often the case is higher than 100%. That is a very sad thing when you're going into a final exam and you calculate, oh, I just need 105% to pass this course. That is not very motivating to study. So there are two more mean questions that I am going to get you to do on your own, and we'll go over them at the beginning of next class.